Hello students. Today let us discuss the topic choosing OC curve for appropriate sampling plan. We have already learnt about double sampling and single sampling plan and the OC curve for those two sampling plans. Now we are going to learn about OC curve for multiple sampling plan. So OC curve for multiple sampling. So the multiple sampling plan is also a continuous process similar to double sampling plan. So multiple sampling plan is a continuous process like the double sampling plan. So the construction of the OC curve for multiple sampling plan is much more involved than that of the double sampling plan, but the procedure with which we are drawing the double sampling plan is same for even the multiple sampling plan also. So the construction of OC curve for multiple sampling plan is much more involved than double sampling plan, but the procedure remains the same. So the data for the multiple sampling plan we will need is the data for multiple sampling plan is as follows. So that is capital N, that is the lot size, N1, C1, N2, C2, N3, C3. So this is sample size for first sample, and this is the acceptance number for first sample. Same way, this is sample size for second sample, and this is the acceptance number for second sample, and this is the sample size for the third sample, and this is the acceptance number for the third sample. The same way, the data is drawn till NM and CM, that is the till the number of, after 3 there are so many samples. Let us consider this is N3, and then after this 3 we have to collect the data till M number of samples. So NM and CM. So this is C3. So many number of samples. So this is for sample size of sample number M, and this is acceptance number for sample number M. So let us consider this m is equal to 4. So we have to take up the data for 4 samples and we will plot 4 curves. So when we consider the value of m is equal to 4, then we have to draw 4 OC curves. So 4 curves. So from the figure we can see that this is probability of acceptance for the first sample, and this curve is probability of acceptance for the second sample. This is probability of acceptance for the third sample, and this is the probability of acceptance for the fourth sample. So here see OC curve for single sampling plan. This is the OC curve for double sampling plan. This is the OC curve for triple sample plan, and this is the OC curve for 4 samples. So as usual on the x-axis this is the fraction defective and this is the probability of acceptance on the y-axis. So if probability of acceptance of combined, it is the probability of acceptance of the first sample plus probability of acceptance of the second sample plus probability of acceptance of third and probability of acceptance of the fourth. So the first curve is for 100 fraction defective and probability of acceptance 1. Second curve for 100 probability of acceptance and probability of acceptance of the first sample plus probability of acceptance of the second sample, that is the combined curve. The third curve is for 100 fraction defective and probability of acceptance of first plus probability of acceptance of second plus probability of acceptance of the third. So this is again the combined curve. Now the fourth one is curve for fraction defective and probability of acceptance of first, probability of acceptance of second, probability of acceptance of third, and probability of acceptance of the fourth sample. So here this figure is showing a typical OC curve for multiple sampling plan with 4 samples. So here there are 4 samples which are shown here. Now the characteristics of the OC curve. So the first characteristic, the OC curve always starts from the point PA is equal to 1 and will be asymptomatic along the x-axis or 100% defective or process quality axis. So this OC curve always will start from the point PA is equals to 1.000 and will be asymptomatic, that is it will not change along the x-axis. Asymptotic along the x-axis, or x-axis is also called as 100% defective, or it is also called as process quality axis. So this OC curve indicates the good and bad lots for given process quality P dash. It indicates the good and bad lots for a given process quality. The C. The third characteristic says that the curve becomes steeper as the sample size increases for the same lot size as shown in this figure. So the curve will become steeper. So here we can see the curve is becoming steeper as the sample size, that is small n value, increases for the same lot size. So if the n value is increasing for the same lot size, we will see that this OC curve will become steeper. So let us write it as figure C. So this is figure C. We can see that for the increasing n value, the curve is becoming steeper. So here it is n1, here it is n2, and here it is greater than n1 and n2, that is n3. You can see it is becoming steeper. The next point says that as the acceptance number increases with lot and the sample size is kept constant, the OC curve becomes steep as shown in this figure. So for the acceptance number, that is the C value, if the acceptance number for the lot, so acceptance number is increasing with the lot but the n value is kept constant, then again the curve will become steep as shown in this figure. So here we can see how the curve is changing with the increase in this acceptance number. So this is the figure D. Let us consider this as figure D. So here change in C value will make the operating characteristic curve steep in this way. So this is all about the OC curve for multiple sampling plan. I hope you have understood the topic. Thank you.